Okay, let's start for the second section. Now, this one is a simplified, okay, about the schematic diagram. For a very simple about the layout, it consists of 4 floors, and then this is the water tank, with some of the stop valve, and then this is the pipe. Now please pay attention. Okay, now this is very practical about the calculation. Now and then for each floor, like a typical residential building, it consists of a basin, okay, WC, okay, water closet, and a bath. And the length of the water pipe shown here. And then, okay, this is the height, and the discharge point is 1 meter. Okay, that means it is a debit. This is not a credit for gained energy. And then, okay, when the water moving downward, gain the potential energy. And it is necessary for us to check about the, say, discharge pressure, okay, whether it provide, okay, sufficient pressure. Maybe you may say, 1 to 3 meter head, okay. This is what we agreed, okay, during the tutorial or something. Did you remember? Okay, this is the okay, about the datas. Now and then this is the main pipe. This is the main pipe. For each so you may ask, for each section, what is the loading unit? So maybe this is the some of the hints. Okay, each WC function table is 2, basin 1.5, bath is 10, and then this is the 15.5 per fat, and then total with 8 numbers of fat. So this is the total loading unit 108. Okay, this is the total loading unit. Any questions? I have no questions. Okay, I shall move to the next step. If 108 here, this is the loading unit, and then the maximum about the flow rate should be about 1.4 liter per second, based on the chart graph A1 of IOP. And then, okay, 1.3, this is the flow rate. Now, but it is necessary for us, okay, to estimate about the maximum demand. Now, if we adopt about, say, taking about the maximum, okay, now this is the simultaneous, because this, this one come from the loading unit, and then that means this is a simultaneously load. You may question about what's happening if all 8 apartments, they operate all the fixtures at the same time. So that means it is talking about the maximum demand. Okay, that means it is necessary for us to find out the flow rate for the basin, maximum flow rate, okay, for the bath, and then times 8. Understand? So this is about 3.6 liter per second. Really about 3 times. Okay, as you compare to the our existing calculation, normal condition of the loading unit. So you may question, okay, why? Okay, this one 1.3, this one is 3.6. Now, if with this figure, just as a reference, it gives you some ideas about the fractional resistance, okay, which has been included, okay, in your design. Because, okay, if you use this one, 1.3 divided by 3.6, this is about the results. It's about the 0.36, and then times 8 numbers. Okay, this is about 2.88. That means, okay, 2 facts you are required to consider. That means maybe, okay, about using, okay, operate at the same time. Okay, this is talking about the fractional, okay, resistance should be considered, okay, when you conduct the design. Now, if you get familiar about the equivalent pipe length, okay, I don't want to reiterate about the details. With different pipe diameters, okay, you can find out about the equivalent pipe length. So this one, okay, with different diameters, okay, you can try something by yourself, but this is what I propose. Okay, all the details related to the data in here. Now, this table, okay, I need to reserve about at least 10 minutes, okay, for discussion. Because for your submission, okay, even for your design, you can use this approach, okay, as to demonstrate about whether you conduct a very good design or not. Now, so first of all, okay, for the pipe length, okay, for the schematic diagram, it consists of different references. Okay, 1, 2, 3, 4, 5, 6, 7, 8. Understand? These two, okay, they are symmetric, same. Okay, just a one-time pipe, and then, okay, for the horizontal pipe, I would say divide to two, okay, branches, two directions, or you may say two apartments. Okay, for the tables, it is necessary for us to identify about the loading unit, the loading unit in here. Okay, so for example, pipe reference 7, this one should be 15.8 loading unit, same as 6, 5 or whatever. Understand? This is the branch pipe. So that means the branch pipe diameter for 5 equal to 6 equal to 7 equal to 8. Am I correct? Am I correct? Yes or no? Any student from the online student online? Yes or no? Yes or no? IDK, what's the meaning for IDK? No. Okay, now Wang Tonghe, okay, correct. Because it even, okay, it connects with the same fixtures, but we don't know about the discharge pressure. Because, okay, this is the branch pipe, we didn't consider about the energy which gained from the vertical pipe. We can gain the energy or lose the energy through the horizontal pipe or the branch pipe. Okay, so in the current stage, we can assume something. Understand? So that means, okay, no, I don't know. So how to do it? It is the first of all, you need to highlight all the loading unit and transform to the full way. Okay, now this one is for trial, or you can use the other term, iteration. You can, now if you are the well-experienced pumper or the designer, you may get some ideas about, oh, for this full way, how about the appropriate diameter. Now, and okay, now so this is if you identify about the pipe diameter, if you identify about the loading unit or the full way, is it possible for us to identify about the frictional loss meter head per meter? Yes or no? Students, yes or no? 唔使望住個同學㗎，望住同學佢唔會話俾你聽㗎。Yes or no? Yes, okay. 俾啲反應喺度。So you can find out this one. And this is the pipe length. Okay, the column 6. This is the pipe length. This is the pipe length. They are all here. Understand? So that means here it's about 4 meters. Am I correct? Okay. Now, and this one, 1 meter total. This section is a 5 meter. Now we discuss about the section 1. Okay, section 1. For this section 1, the pipe length 5 meter, no problem. And this one, it consists of 1 elbow and 1 numbers of the valve. WAF elbow. 係咪啊? Okay. So we have some suggested numbers, suggested diameter of the pipe, 42. So what is the equivalent pipe loss for the diameter of 42 for elbow? 42. Let me check. 42 here. 1.7. Am I correct? 1.7. Yes, this one. That means 1.7. 1.7 plus one of the stop WAF. 40. Okay, here it's about 0.5. It's about 0.5. Okay, now some numerical error, whatever. So nearly about 2.3. Okay, now so this is about the equivalent length. Now, but the length of the pipes is from 2.3 plus 5. That means 7.3. 8 is a column. 6 plus 7. Can you follow? Okay. So, what is the final frictional head? How to calculate this 0.29? How to calculate? Any calculator in here? 0.29. How to calculate? Please, yeah. Use your iPhone, use your mobile, or wherever. Do you know how to calculate this column number 9? Any suggestions from the podium? Or some student on the web? Total length. Correct. Okay. Wang Tonghao, you're right. Total length. That means in order to make it simple, column 8 times column 5. Am I correct? Okay, so this is 0.29. Now, because that this is the first section of the pipe, the progressive resistant head loss is same as this one. And by the WAF A1 in the IOP guide, you can also check about the velocity. And the static head available. How to calculate this 3.71? Any suggestions? Yeah, student. Okay. How to calculate this 3.71? This 3.71, how to calculate? Now, that means in here, you are required to identify the pressure for this point. The gain of potential energy. How about the meter head? How about the meter head, which we gained for the energy for the section number 1? Height existing. Yes. So what's the number? 4. Thank you. 4. Okay. But for this section, the loss of the frictional loss is about 0.29. So that means correct. Okay, Zhao Tonghe. Okay, use about 4 minus 0.29. This is a 3.71. This is the static head available at that point. But for the section 1, is it necessary for us to calculate about the head available at the outlet? No, because there are no discharge for the section number 1. Am I correct? Okay. Now, second, I can take care about this path. this section, this pipe, and we need to check about the discharge pressure. So for this one, how to do it? First of all, we don't know about the diameter. We need to assume something, 22, 30 something, whatever. And you are also required to find out the equivalent pipe length for this section. Understand? Now, you may ask one question, Horace, how about for this one? For the last section of the pipe length, it connects to the fixtures. It is not necessary for us to consider about the loading unit for this last section. Do you know why? Because for this last section of the fixture, just you use it or not use it, we are not required to consider about the simultaneously load. Understand? If you operate, turn on, okay, the valve, that means full load. This is the pit already. So that means for the last section, please don't take care. Okay, oh, for this last section, the basin, the loading unit is 2, and then I use the 2 loading unit and then transform to the 4-way. No, because the last section, okay, I repeat, last section, you are required to consider as a pit operation because 0 and 1 only, on off only. Okay, without use 0. You turn on, this is a maximum flow already. Understand, student? 明唔明啊? Understand? Okay, now, okay, go back to this section number 5. It consists of some of the stop valve and some elbows, whatever. So how to do it? Section 5. Okay. So we consider about the section 5. Now, section 5 is a much complicated looks. Now, if we assume the diameter 28, the loading unit we identify already, okay, because each section they are same, because the same, okay, numbers of fixtures which connected to each branch pipe. 4-way same. Am I correct? Okay, now, but maybe you may ask, Horace, why for section 5 you use 28, but when I observe about this table, for the other section you use 22. What's the main reasons? I make this recommendation or suggestion. Now, don't say I know the solution. I perform some calculation already. No. Why? I make this assumption. Do you know why? Now, the main reason is because for the pipe number 5, it is located in the top, nearly the top 4. The static pressure which gained by this branch pipe is not so significant. That means I can't say oversize, okay, make the diameter, make it much larger. With the same 4-way, the pressure loss should be lower. Continuity equation. So that means I can fulfill the requirement, say for the discharge pressure, maybe within my expectation. Maybe in the lower part, I can make it smaller for the pipe size, because in here, sufficient gain of the potential energy. Maybe we gain a lot. We use the pressure reducing valve to reduce about the pressure. Okay, artificially create some of the, say, friction, or you can say. Okay, so now the static head here is 3.71 in this point. Am I correct? Now 3.71, but I concern about what is the pressure for this point. Okay, I can't conclude. Okay, Wang Dongho. Okay, he asked static head at that point too large. Now for that point here, 3.71, I don't care, because this is not the real discharge pressure. I need to check about the discharge pressure. Okay, how to calculate? Sorry, the frictional, according to the graph A1, I found out the frictional per meter head. The pipe length 5 meter. Let me check about whether it is 5 meter. Yeah, because for this section, this is 4, and then this is a 1. Understand? So also 5 meter. And then you use the table to find out the equivalent length, elbow, T, tap, and the valve. Now, and then the 11.3. Now, I don't want to repeat, okay? I believe you get familiar about use the equivalent length table by yourself. Use about the column 6 plus column 7. This is 16.3. Understand? Okay. Now, 16.3. Okay, and then use this one, the frictional head, 16.3 times 0.025. This is 0.41. Please help me to check whether I'm correct. Please check whether my calculation is correct or not. Okay, thank you. Okay, in here is 0.41. Thank you. Okay, the student from podium. Now, the progressive resistance head in here. What is the progressive resistance? That means use this one plus this one. For this case, 0.29 plus 0.41, because this is the progressive pressure loss. Now, I make it simple, okay? Because I consider this path. Understand? So we did something for this part. And then the second part, I calculate for this. Okay? So this one, the pipe section number 1, pipe number 5. This is the progressive frictional loss. Understand? Okay. So this is a 0.7. And okay, for this 0.7. Now, at that moment, okay, for this one, what is the static head available? How to calculate the static head available for this issue? For the previous, the point 3.71. Okay? For this section, is loss about 0.41. Understand? So 12 minus this one equal to 3.3. Understand? Understand? Oh, okay. Now, if this one 3.3, but when you go through about this schematic diagram, here, 1 meter. That means this is the loss of energy, because the water will be moving upward. You can't gain the gravity force, lost the potential energy. So at the end, -1. So 2.3. 2.3, this is the discharge pressure for the pipe section number 5. Understand? Thank you. Okay, now, so if you get the concept, okay, for this, okay, table, you can use this concept to proceed number 2, number 6, number 3, and number 7 respectively. Now, in the PowerPoint here, I use some color to indicate, okay, to let you much easy, okay, to follow. Now, I suggest, okay, you both go back to home to take care for the rest of the pipe. Okay, you try by yourself. Same procedures, but maybe sometimes you get confused. This section, that section. Okay, some maybe some problems, but don't worry. Okay, I just use this and I indicate some of the colors. Okay, let you much easier to follow. Now, so 周同學 okay, understand already, okay, you okay. Now, As a good engineer, we may use this approach to check about the discharge pressure head. Now, frankly speaking, in this table, is it you are set about 5.98 meter head discharge pressure? No, too high. Am I correct? It's because you are set about 3 meter head, maximum 4, but this is nearly about 6. That means we get trouble. Understand? Okay, that means you open the water tap. This is a high fire hydrant. I guess I will not use it. It's too extreme. The discharge pressure too high. So how to deal with this problem? Oh, you say, Horace, I try my best to reduce the diameter. Okay, make it smaller. But the smallest one is 22. And may I use 10 or whatever? No, too small. Okay, so how to do it? Any solution? Any solution? How to reduce the pressure? Brick 10 too bulky. Yes, exactly. We may consider about the use of a PRV, pressure reducing valve. If, okay, in here, for marginal, I accept. If I use about the 2:1, that means, okay, the PRV, if I use the 2:1, that means the discharge pressure may be dropped to the 2 meter head only. And then start the calculation again. Understand? Now, some students, they are very interesting. They add say a lot of pressure reducing valve for their design. I would say totally wrong. Practically, 10 for us, we may reserve 1 PRV. This is the norm. If I go through your design, okay, each 4 you add 1 PRV, I would not read in detail. I would say your design is totally incorrect. Okay, you may say, sir, I conduct a very, very nice about the calculation, very narrow range of the discharge pressure, which I controlled. I will say, this is not good. This is not the perfect design because, okay, without any flexibility. Okay, so the norm, 10 force, 1 PRV. This is the experience, okay, from the industry. Understand? Okay, thank you very much. So this is the details. Okay, you can go through, okay, by yourself. And this is about the FH consumption. Now, so today, the slides, the information, the graph, which you can use for the design, for your design. If you dislike about the concept for the equivalent pipe length, you can use the tables, the graphs, okay, which I introduced during the lecture. I'm open. But for the pumping design, I recommend please use the IOP approach. Because for the compressed gas calculation, I shall introduce about the CIBSC Guide 4, C4 table, okay, the other issue. Okay, now let me reiterate again for the design procedures. Even, okay, you are the designers, you need to check about the layout from the, say, the floor pan, okay, for diversion. Where is the main water pipe? Where is the main discharge drainage pipe? And then locate, okay, about the supply. I recommend double end because if right hand side the freshwater system get trouble, and then so you can use about the left hand, okay, the other way of the water supply. Okay, and for the design, you are required to consider about the loading unit. But okay, this design should be based on one assumption: normal usage, not for the pit usage, not for the industrial building usage. Otherwise, we can't use the loading unit. You are required to use the design flow rate, the pit design flow rate. You need to identify about the supply of the water. 99%, we shall equipped with a consider about the indirect supply, because to prevent the contamination of the main supply pipe. But for some of the cities, they may say use a direct supply. The other reasons why we say consider about the indirect water supply, because of Hong Kong we use the two pipe system. The two pipes, that means seawater for flushing, fresh water for potable water. And some of the workers, okay, they make some serious mistake for misconnect about these two pipes, okay, and then some water, okay, will be contained about the say the government main supply. So it is good for use the indirect supply. Okay, and then the storage tank, okay, which the capacity, location, the material which used, the pipe materials, we check about the flowway velocity, and then you are also required, okay, to take care about the layout plan or for some vertical line diagram. I shall give you some example afterwards. Now, this is the record, okay, for example, fresh water and say flushing water. This is the main water pipe. Now, how to identify about this? Okay, there may be something in here. Okay, so this is about the main pipe. And then if your building, okay, for example, located in here, so it is good for us to identify, oh, about the pump worm or the water come from this direction, much easier. Or okay, if you consider about this is the main supply, okay, you can consider about the pump worm, okay, which located in here, or the water meter. Understand? So that's why after you graduate, okay, now is I guess much easier. A lot of electronic media, electronic files, which you send a request from WSD, maybe send you a PDF file or a DWG drawing. But long time ago, I need to visit about the DSD or WSD and then get some A0 drawing and then check by myself, okay, take some photocopy and something, okay, long time ago. Okay, now it's a much digitalized about the files, okay, so much easier for you. Now, and then we identify about the site plan, okay, this one is a very small house, okay, and with some small, maybe the cup house or something, this is a small building. Now and then, okay, for the drawings, okay, if your future, if you submit some drawing, it is necessary for us, okay, some students, they ask, by the way, tank gas installation for residential is handled by the BSc designer. I shall discuss this compressed gas installation, okay, student Wong, okay, afterwards in the gas supply, okay. Some of the gas may be handled by the BSc. If we're talking about the tank gas, now, if you are working in tank gas, I may say yes, okay, but you need to follow a lot, okay, tank gas with some of the internal standard. If you are working in tank gas, say, I will say yes, but if you are not working in the tank gas, I will say no, okay, it depends on the designer, okay, in the tank gas company, okay. Go back to these drawings. This is the general notes. Okay, now most of this legend, some of the notes, they are standard. Okay, even you get some standard drawings from WSD, similar. But okay, you can modify, okay, by yourself. You need to take care about some of the gate valve. Okay, what's the pipe? Okay, copper pipe for fresh water, for the other cleansing water, UVC pipe for flushing water. There may be different line type. So that's why, okay, for AutoCAD, okay, you need to select different line type or with different colors. Now, but the point is, different color is very eye-catching. Am I correct? But the point is, if you print back and write for some drawings for submission, oh, you may get trouble. So, as I'm the old guide, okay, I'm the traditional engineer, BSc engineer. I love to use different line types to represent different types of the water pipes. Understand? Okay, materials, no choice. Okay, copper pipe in Hong Kong. Flushing, UPVC. this is the tables which I introduced, okay, according to my previous lecture. Now, so the ground floor, this building is simple. In your submission, you can say do something similar to this one. For example, you need to highlight about the routing, the pipe routings. Okay, different color, that means there are different pipes. And then you are also required to consider about this one is the water meter. Okay, under the staircase. And then, okay, the pump, okay, to the pump room. Okay, because the water, something about the pumping, something about for the kitchen, something about for the fire services. Okay, so step by step, cleansing water, potable water, flushing water, fire services. And afterwards, okay, you're required to identify the labels. Now, so for the labeling, okay, so because the drawing is 2-dimensional, am I correct? So in this case, oh, sorry. What's the meaning for HL? What's the meaning for TA? Do you know? HL, high level. TA, to above. TB, to below. Understand? Okay, very simple. Okay, high level, low level. So that means, okay, that means that this one, for example, for this one, 50 diameter mm of the water pipe, okay, at the high level to above. Okay, so that means at the high level or near the ceiling, and then moving upward. Understand? So it indicates about the direction of the water pipe. So you need to get familiar about these abbreviations. For the first floor, okay, also step by step. Okay, for example, from above to below. TL, what's the meaning for TL? To below is moving to the downstairs or something, yeah. If I'm second floor, go to the first floor. So TL, what's the meaning for TL? To low level. That means still in this, okay, level, but in the lower part, okay, of your floor. So that means you need to get some, I can't say this is a real 3-dimension drawings or something, okay. Roof, okay, and then you can also write down step by step in here. Vertical line diagram. Now this one is very, very important. That means it indicates about the, okay, connection, the numbers of fixtures, diameters in here. So it is, I can't say, I don't want to use the term, it is necessary for us to submit some something similar to this one, okay, for your design. But this is one of the reference. One of the reference. Okay, I make it larger. Okay, cool water pipe for potable water, fire services. Okay, now so this is something. Now, low fee lunch, low fee water. I will use this term. For different fixtures or for different purpose, it is necessary for us to install different types, different numbers of meters. Now, for your building, if it connects with some of the restaurants, we need to reserve separate meter and separate water tank, separate small size of the water tank. Okay, flushing water can't share with fresh water. The check meter position you are also required to take care, not for public, because okay, only assessed by the WSD, okay, the staff from the WSD, and the WSD authorized person. Okay, otherwise they can't, you can't make any inspection, okay, for the water meter. Okay, and then we also say this table show about the schedule. That means the numbers of fixtures in different floors. Okay, points of sanitary fittings. This can be also, this table can also print in the big drawing, A0 drawing or the legend, okay, of your design. Water capacity calculation, I told us already. Follow these tables, okay, which I introduced. And then if this is the total water capacity which required, but maybe you can identify, for example, 30% at the ground floor, 70% at the roof. So it is your decision. It depends on your decision. You are the designer, you can make the judge by yourself. Daily consumption calculation, also I let you know in advance. But okay, for some of the special purpose, then maybe use the PIT calculation flow. This class A2, okay, you need to pay attention. Okay, if you're the pumping designer, you are required to use it until you get retired. Okay, and okay, if you say I have no ideas about the main part, about the size or something, you can use about the use this as a quick method for calculation without the graph A2 which I introduced. Submission drawings, okay, in the future, this is the required. The first one is the legend, a lot of the simple abbreviation notice. And then one drawing talking about the pan, about the main direction, diversion, where is the main water supply pipe, okay, and then where is the main, say, connected to your buildings, layouts, schematics, some detailed drawings, okay, if required. Okay, submission, I discussed already, okay, at the beginning of the lecture. Okay, there may be several submission. Now you are not required to remember submission, okay? Just read about the information which shared by the WSD, that's fine. This is the reference. But according to my information and my experience, okay, you are not required to go to visit the library to get some reference, okay? You're not required because I give all the related materials, okay, to you both, okay, don't worry. Okay, now this reference most of the time, okay, can be downloaded from the WSD or something. Now I try to speed up, okay, just some sharing snapshot for some installation. Okay, you may criticize, sir, okay, all the designs in the two-dimensional drawing. How to judge whether my design is good or not good or bad or whatever. So there may be something about the back package pumping installation. Okay, that means, okay, in a facade of the building, okay, it faces to the main road, and there may be a lot of the water pipes in here. So this is not a good design. Okay, the outlook is not nice. I will use this one. Okay, but maybe they make some renovation for some of the old buildings, okay, for the existing pipe inside the buildings, inside the pipe duct, okay, get trouble, so they make some diversion or the other alternative design. So this is not good. Okay, so maybe especially for some building with some curtain wall, it is impossible to conduct the design in this format. But this design is only one good for one issue, maintenance. Okay, but you need some of the scaffoldings. Maybe, I don't know, I can't conclude, okay, whether this is the best approach. Okay, so whether you love this, I'm open. Okay, but just share with you, okay, whether this is a good design or not. Okay, so you know. Okay, this for the rainwater, for the drainage. Okay. Now this is the external for the facade of the building. But I will share something with you for the internal. Now, for your toilet, if use this, if your washroom like this format, whether you feel comfortable, Now, for the students, okay, if you are living in Ho Man Tin Hall, like this format, very ugly. I'll use this term. The main reason is long time ago, okay, we say all the pipe they are installed inside the pipe duct, but due to the leak issue, so we need to change, okay, install the new set of the freshwater pipe. So that's why no choice, okay, we use this approach. But this is not good in terms of the outlook. If this is a luxury apartment, you may complain. Am I correct? Okay. Yes, this is not good. Okay, you can imagine about your ceiling like this. This is the drainage pipe for the upper floor. You can help about your say your friends and neighbors, okay, and then to keep the maintenance for the drainage pipe, okay. So okay, it is good to do something, okay, use some of the cabinets or whatever, make the pipe inside, okay. Yeah, looks much better. And then we use some of say some of the, I can't say chamber, okay, yes, some of the resurface some of the areas, okay. This is the use of I can't say gypsum board, okay, use the other panel systems, and then let the piping, okay, reach behind, okay, inside the, I can't say this is the pipe duct, is the pumping ducting system, okay. All the pipes, they are all installed in here. So this is much easier, okay, for say some of the pipes, okay, installation, okay. Even for public toilet, this is good because this is a panel system, much easier for maintenance. Yeah. Okay. Now, but the one issue I would like to address is about for the drainage. Now, pumping drainage, this is a design. Pumping, we need to maybe if all the pipe concealed in the pipe duct, okay, you may get trouble. It's not easy to conduct maintenance if some of the damage of the water pipe. And then for the drainage system, it is also say necessary for us to conduct some maintenance, clean the drain ponds, cleansing ponds, whatever. So the location of the self-siphonage U-trap or something, it is the other issue, okay? Please consider. Now for each of the sink, wash basin, there may be some of the siphonage U-trap in here. You can conduct the maintenance by yourself. But for the branch pipe, okay, for example, it connects to the stack. So you need to pay attention about the location of this one, whether it is accessible or not. So if a good designer, you also need to pay attention about this. If you want to cleanse about this pond, you need scaffolding. Wow, this is a big job. Understand? Because if you request a scaffolding for your apartment, it consumes maybe $10,000, or maybe just take care for U-trap, you need to reserve a $10,000, too expensive. So it is necessary, okay? If you are the contractor in the future and the site, you need to take care about this issue. Maybe the consultant, okay, there may be just to conduct the design a two-dimensional drawing, they don't take care or don't realize about the problems, okay? So maybe this is the one of the duty, okay, for the cut-off works or the contractors, and then to take care about the location, okay, of the trap. Now, and so that's all for this PowerPoint. Now, and I want to share the other PowerPoint. Now, I upload something, okay, to the Blackboard. One is about the design guide. Now, this pumping design guide, I make summarize something, okay, and then make it as several pages, okay, for your reference. This data, okay, maybe if you are lazy, if you are willing to conduct the design, you can use this one. because this guidelines is extracted from some of the consultant, okay, when I'm working in a consultancy firm. Okay, so this is not follow for WSD and something, some just share something with you both, okay? And the others, okay, two more, okay, slides or the say something I want to share with you. One is about the big water supply example. Now, if you are required to manage, okay, something after you graduate, this is a big project. Now, this is the, okay, the size for this one is 1 to 200, the scale. And then, okay, for that, this is the official, some of the submission. In here, okay, is notes. Okay, right hand side is notes. Sorry, I try to open the software and then can highlight something. Sorry, wait for a few seconds. I open the files. Okay. Wait for a few seconds. The file size is big, okay, for this PDF. Now, this one is the notes, okay, and then this is the legend. Okay, now here is the legend and some abbreviation. This is the official, some of the submission. And here, there may be a lot of notes. Because of something, okay, you can't draw, okay, show in your drawing. So that means, okay, that means that sometimes, for the piping without any notification of the pipe diameter, okay, must be 22 mm. Because the last section of the pipe, it is, say, maybe you are not required to adjust, to write down the dimension. So we may use this one. Now, so there may be all in here, and then all the pipe, okay, fulfill the standard, okay, for the British standard. Now, so there may be a lot of informations in here, okay? Understand? So this is about something, okay, you can't show in the drawing. And then the drawing. This is the boundary. And then, okay, this is the main. And this one is connected to your building because this is the boundary of your building. Understand? Student, they asked me we cannot use this table. Yeah, okay, okay, I share with you afterwards, okay? Now, so this is about the first drawing. The second one. Now, there may be a table. It shows about the schedule of draw-off ponds. That means for each floor, it consists of, say, WC, basin, and something. And then the numbers, they show all in here. Okay, that means for the QS, okay, they count the numbers, okay, and then for tendering. And then the drawings in here, this is the boundary, as I mentioned. This is the water meter box. And then this, okay, pipe size, it depends on the BSE. Okay, you are required to do something. Okay, one by one. So for this, the other floors, showing here. And okay, for the washroom, okay, they try to do something for the pipe size. So it indicates about the diameter and the connection. Now, I give you hints. 99% of the time, for the pumping and drainage, you are required to prepare one-line drawings only. But for the air conditioning, chiller water pipe, maybe its size over 300 mm, so very big in size. So we may consider to use about the two line joints, double line joints. Okay, that means up to the scale issue. Now, and then the other joints, okay, they're all shown in here. Okay, this is what, okay, you are required to conduct the design. For example, okay, this one, 25 mm, okay, flushing water pipe from above to below. Cold water pipe, flushing water pipe, one at high level. Very simple. This one, direct supply. Okay, this building, you use a direct supply, then may from below to above. Okay, all in here. Now, for your assignment, okay, I remember there may be 6 or 8 numbers of typical facts for your layout. For your design, you just concentrate, okay, about the details for just one apartment. That's fine, because I assume for the rest of the apartment they will use the same, okay, size of the water pipe, the same the layout, just mirror or symmetric. Understand? So you just concentrate for one, just for, because for the mini design, it is necessary for us to demonstrate, okay, you are familiar, okay, to conduct the design. That's all. Okay, I'm not say I don't want to kill your time for conduct the design, conduct a lot of donkey work, okay, about the say. So that's why just a one layout is fine for submission. This is nice. Okay, I'm willing to see something in this format. This is the layout. This is the layout. And at the end, this is the schematic drawing. If I want to overlook, okay, take a quick look about your design, or whether you use the direct, indirect supply, where's the location of the tank, where's the size of the water tank, okay, you can use below this one. Because in here, okay, oh, for example, for here, I get some ideas. This is the, okay, size of the water tank, and then, okay, with some of the pneumatic pump, okay, because it serves the topless floor, okay, because there insufficient, okay, discharge pressure. Oh, and this is the, okay, here, okay, about the pipe. Oh, it connect with different toilets, okay, study room toilets. Okay, so this is about the schematic drawings, okay, which you are required to prepare, okay, because one for the, say, for different purpose, okay, for cleansing, this for the general purpose, okay, and show in here. And then this is the suntan. Suntan, where is the suntan? Now here, this is the suntan. Okay, and then this suntan, okay, that means something will be deliver the water, okay, to the top of the buildings. Okay, then maybe I will recommend you separate. Okay, now in the design, if I'm correct, you are not required to conduct the flushing water design. Am I correct? I don't remember. Okay, now don't worry. Okay, because the design for the fresh water, flushing water, I treat it same, except for the discharge pressure. Because for the flushing water pipe, you are not required to discharge the water pressure. Do you know why? Because all the pipe, the water will be discharged to the back, the water tank, the small water tank of your WC. Okay, that's you are not required to consider the discharge pressure. So, okay, at least, okay, you are required to submit something for the fresh water only. Flushing water not required. If you want, I'm appreciate. Understand? Okay, and then this is some of the detailed drawings. And I want to show one more about the last PDF files. Now this one is not so complicated. Okay, this is the other design drawings. Okay, as example, okay, for you both. This is a much simple, some of the standard drawing. Okay, direct supply. If something about the gravity supply system, how to prepare the drawings. You can use this as a reference for your submission. Okay, much simple. If you are say at the first round, first time to conduct the design, please read about all these drawings. Okay, you can use this. Okay, I can't say copy. Okay, you can use this as a reference. Okay, but maybe the problem is, okay, you need to make some information, updated information about the size, because this standard drawing didn't mention about the size, okay, of the water tank. So maybe give you some reference. Okay, now I didn't give you any break, okay, for this, this lecture, because I'm worried about a lot of information. Okay, I can't finish. Okay, share with you both, and I believe you have some questions you're willing to ask. Now, so officially, okay, I stop here for the lecturing. Okay, for lecturing, and then I stop the recording, and then you may ask me some questions afterwards.